Hello. So I have from question 20 to 30 to solve, and we're done with this lesson, all of the lesson, okay? Again, just verify each identity, and here's number 20. So I need to make this something equal to sine theta, okay? So how did I start? I started by distributing. Over here I got cosec theta minus cosec theta cosine theta plus these cotan theta minus cotan theta cosine theta. This is a reciprocal identity, minus 1 over sine theta times cosine theta plus cosine theta over sine theta. This is cotan theta, and this cotan theta multiplied by cosine theta. And let me see what will happen to me after that. It will happen is very good. Now here minus, I'm just gonna write this up here, cosine theta over sine theta plus cosine theta over sine theta minus cosine, I'm gonna multiply this by this, cosine squared theta over sine theta. So this is canceling this, and here I'm left with a Pythagorean identity, 1 minus cosine squared theta over sine theta. This is a sine squared theta over sine theta. If you cancel this with this, you're gonna get a sine theta as an answer, and you're done. Okay, for question number 21, I started by working on this side, actually not this side. If I work on this side, again it's your choice. If I worked on this side, I'm gonna change this to sine squared theta over cosine squared theta minus sine squared theta. To be able to subtract them, I need to multiply by cosine squared theta over cosine squared theta. So I'm gonna get sine squared theta minus sine squared theta cosine squared theta over cosine squared theta. I think I should take a common factor as sine squared theta, and here I will have 1 minus cosine squared theta over cosine squared theta, right? Over cosine squared theta. And 1 minus sine squared theta is sine squared theta, right? So I'm getting sine squared theta times sine squared theta over cosine squared theta. And what is sine squared theta? Sorry, over cosine squared theta, it is tan squared theta. So I will get tan squared theta times sine squared theta, and this is the right side, sorry, the left side of the identity. So here I started from the right and I reached the left. There's no problem. Start from the right and reach the left to right. Work on both. As long as you prove they are equal, you're very good. Question number, where am I? 20. All right, this is 21. Okay, question number 23 over here. Okay, probably I'm gonna work here on this side. I'm gonna change it to 1 plus 1 over sine theta all over 1 over cosine theta. Type, of course here I need to multiply by sine theta over sine theta. To cut it short, it's sine theta plus 1 over sine theta all over 1 over cosine theta. Okay, so basically it's the same as sine theta plus 1 over sine theta times cosine theta. صح? صح. Okay, so if I distribute the cosine theta here, I am gonna get sine theta cosine theta plus cosine theta over sine theta. Okay, and this is going to lead me to, if you once put this over this and this over that, you're gonna get the answer. Here you are, sine theta cosine theta over sine theta plus cosine theta over sine theta. This will cancel this, and you're gonna get out of this cosine theta, and these over each other are cotan theta. and you're done. Question number 24. I worked on the left side. Here it's the same bracket, or I will just do a first square, last square, and the middle. 2 by a by b. Remember this, a minus b all squared is equal to a squared minus 2ab plus b squared. So if I want to break this bracket, I'm gonna work on cosec squared theta minus 2 times cosec theta cotan theta, which is the most important part because you always forget it, plus, because a negative square is going to be plus cotan squared theta. So what do you think I can do over here? I can change this to maybe 1 over sine squared theta minus 2 over sine theta. I changed the cosec to sine times, this is a cosine over sine, just to see everybody, plus anything that's hidden, I want to see it. طيب, okay. So basically I have all denominators equal, if you can see. Minus 2 cosine theta over sine squared theta plus cosine squared theta. Don't go back to cotan. You do not do the step and then cancel it by in the other step. So I can say 1 minus 2 cosine theta plus cosine squared theta all over sine squared theta. I can rearrange this so you can see I can open 2 brackets for this. I would just rearrange it. It's something squared minus 2x squared plus 1 all over sine squared theta. My answer is full of cosines, so I think I'm gonna need to change this to 1 minus cosine squared theta. This is the same as x squared minus 2x plus 1. Its factoring is xx minus 1 minus 1. But my x here is cosine theta. So I have a cosine theta minus 1 and a cosine theta minus 1. مظبوط؟ مظبوط. All over sine squared theta is 1 minus cosine squared theta. So I have a cosine theta minus 1 times cosine theta minus 1 all over. This is difference of squares. It can be 1 minus cosine theta, 1 plus cosine theta. مظبوط؟ مظبوط. طيب, if I want to cancel this with this, then I just need to put a negative outside, right? Now I want to cancel this with this, or this with this. They are the same. This one, this and this, they are exactly the opposite, or this and this. If I want to cancel them, I can cancel them, but put a negative outside. A negative outside كده, وبعدين cosine theta minus 1 over 1 plus cosine theta is the same as your question, because this negative will affect, let's say it affected the numerator. It will affect either the numerator, either the denominator, not both of them. Okay? So, if I multiply the numerator by negative, it's going to end up in 1 minus cosine theta all over 1 plus cosine theta. على فكرة, if I didn't do this switch, if I worked directly here, I would have got 1 minus cosine theta and 1 minus cosine theta, and I wouldn't have needed this step. But anyways, I proved the answer. I proved the identity. Question number 25 over here. I am gonna work on this side. 1 plus sine squared theta over cosine squared theta over 1 minus sine squared theta over cosine squared theta. Here I need to multiply by cosine squared theta over cosine squared theta, and here I need to multiply cosine squared theta over cosine squared theta. You will end up in cosine squared theta plus sine squared theta over cosine squared theta all over cosine squared theta minus sine squared theta over cosine squared theta. طيب, this denominator is the same as this denominator. They will cancel each other. Pretend you multiplied by the reciprocal, so this cosine came up. Now I'm left with this, and 1 in the numerator, I know it very well. Now this is equal to 1. So I have 1 over, this is a difference of squares, and I don't need that now. No, it's, yeah, I don't need to do that now, because I can say the answer is 2 cosine squared theta minus 1. So I would rather change this to something that has a cosine in it. So I have cosine squared theta minus 1. Remember to open the bracket, cosine squared theta. And why did I do that? Because I'm looking at the answer that I want to reach. طيب, do not just stop thinking about the answer. Minus 1 plus cosine squared theta, and this is the answer, 1. I have 2 of those. So 2 cosine squared theta minus 1, I proved it. Regarding question number 26, I would work on here. Tan squared is sine squared over cosine squared times cosine squared theta, and this will be solved in one step. This cancels this, and sine squared theta is equal to 1 minus cosine squared theta, Pythagorean identity. And here you prove 26. I am left with, I think, 4 more questions. 27. If I work on this side, I'm gonna get 1 over cosine theta minus cosine theta. Here, multiplied by cosine theta over cosine theta to make the denominators equal. 1 minus cosine squared theta over cosine theta. 1 minus cosine squared theta is sine squared theta over cosine theta. If I'm thinking properly, I would think sine theta times sine theta over cosine theta. And this piece is equal to tan theta. And here is, I am not picturing what I'm writing. Here's the answer. Question number 28. Difference of squares. It can turn into 1 minus tan squared theta, and the other bracket 1 plus tan squared theta. How did I know? Because this can be 1 by 1, and this can be tan squared theta by tan squared theta, and this is a minus. So it's a difference of squares. So again, I have one identity here, tan squared plus 1 equals to sec squared. So 1 plus tan squared theta is equal to sec, and I can see secs in the answer. So I'm gonna write this as 1 minus tan squared theta. I'm just making the steps longer, and this is sec squared theta. Okay, I'm gonna work on this one again to change it to, I know this identity by now. I'm gonna work on tan squared theta to change it to something that has sec in it. So it's sec squared theta minus 1. Why am I doing that? Because I'm looking at the answers. So 1 minus the tan squared, open a bracket, it's sec squared theta minus 1 times sec squared theta. Here I have 1 minus sec squared theta plus 1. I'm distributing the negative, times sec squared theta, right? So now I have 2 minus sec squared theta times sec squared theta. Distribute, you will get 2 sec squared theta minus sec to the power 4 theta, and this is the answer. Regarding question number, I have 29, and that's it. I have 29. Okay, I'll stop at 29. I planned until 30, but anyways. Cosec theta minus cotan theta times cosec theta minus cotan theta. Okay, the same bracket multiplied by itself twice. So here this can be changed to 1 over sine theta minus cosine theta over sine theta, and this is also 1 over sine theta minus cosine theta over sine theta, or two of them yani. Anyways, I can directly from here say that I have 2 of those. So anyways, now I have over here 1 minus cosine theta over sine theta. I think I got tired. And here 1 minus cosine theta over sine theta. Okay, if you distribute, you're gonna get 1 minus 2 cosine theta after simplifying cosine theta, and here plus cosine squared theta all over sine squared theta. Let's work on this, make it 2 brackets. One bracket will be 1 and 1 minus cosine theta minus cosine theta. If I multiply minus cosine theta by minus cosine theta, I'm gonna get 2 cosine squared theta. 1 by 1, I'm gonna get 1 minus cosine theta. Minus cosine theta is minus 2 cosine theta, so we're good and everything is right. Okay, all over sine squared theta. I'm seeing here it's full of cosines, so it's better now to change it to 1 minus cosine squared theta. And you could have done this in one step and changed this to 1 minus cosine theta, 1 plus cosine theta, because this is difference of squares. So now I have 1 minus cosine theta times 1 minus cosine theta over 1 minus cosine theta and 1 plus cosine theta, and I'm seeing the answer now. If I cancel this with this, I am gonna get the answer. Thank you, and thank me. Bye. I'll send you the homework.